Okay, lesson, it says here 5.1, but it's actually going to be like, this is unit 7, I think. I'm doing things in a different order this year. Okay, so activating prior knowledge. What does 5 to the third power mean? It means that we have 3 5s multiplied together. So 5 times 5 is 25. And then 25 times another 5 is going to be 125. But remember that the exponent means how many of those individual numbers we have multiplied together. So our purpose today is to learn how to simplify exponents, in other words, powers. And we see these in a lot of different kinds of equations for lots of different kinds of careers. So you'll be able to rewrite an expression with exponents as a single number. So when we see something like 7 to the third, we call the 7 the base. And then the 3, we can either call it the power, or we can call it the exponent. So what's another way of writing the 3 to the third power? That's going to be 3 times 3 times 3. So examples, 4 squared, we saw that a lot last unit. You just have 2 4s multiplied together. And as I showed earlier, 5 to the third is going to be 3 5s multiplied together. Now, how about if we have a fraction? How do we do that? Well, we just write down a fraction, and we have a power of 2, so we're going to make it 2 times. And when you multiply fractions, you multiply the tops, and you multiply the bottoms. And then you simplify if you can, and we can't here. But notice I could have done a shortcut. I didn't have to do this little bit here. I could have thought to myself that I'm just going to simply raise the top and the bottom to the power of 2. So this power of 2 goes to the 3 on top to make the 9, and we square the bottom to make 16. So when I see 3 fourths squared, that's the same thing as 3 squared over 4 squared. The 2, or the power, goes to the top and to the bottom. Okay, now, in this kind of a situation, the parentheses make a big difference. It may not look like it makes a difference here, but it does. Okay, so the power only acts on what is immediately below it. When I have this, the thing that's immediately below the 2 is the 5. And so it is the 5 that is squared. So I have 5 times 5, and then I bring the negative sign over. So this is going to be negative 25. In the next case, we have the parentheses that's happening underneath the power of 2. So I have 2 parentheses that are multiplied together, and each one has a negative 5 in it. And so that's going to be positive 25. So examples here. We have the power of 2, and immediately below it, we have parentheses. So that means that we have 2 parentheses multiplied together. On the inside, we have negative 7. And so that multiplies out to be positive 49. in the next case, the thing that's immediately below the 2 is the 7. So we have two 7s that are multiplied together, and then we bring down the negative sign. So you multiply this, and it's going to be negative 49. For letter C, again, the power of 3 is only acting on what's immediately below it, which is only the 3. Then I bring down the negative sign. So this is going to be negative 27. In option D, immediately below the power of 3 is the parenthesis. So I have 3 parentheses multiplied together. Each one has a negative 3 in it. So now negative 3 times negative 3 times negative 3, it is still negative 27. So sometimes when you have the power with no parentheses, it's a negative, but sometimes, I said something wrong. I better not say nothing more. I was going to say something wrong, and forget it. Product rule for exponents. Let me clean this up here a little bit. Okay, to do multiplying and subtracting and dividing and all that kind of stuff with exponents, it's convenient to think about what is the easiest thing to do, and as you get into math more and more, what are the harder things to do? Okay, the easiest thing to do is nothing. When you are in preschool, all you're doing is you're just looking at numbers and maybe naming them, but you're not doing anything with the numbers. Nothing. The next thing that's easy to do is like in kindergarten or first grade, you'll learn to add and subtract. And then later on, I don't know, second grade, I think it was third grade when I was in school, the next more difficult thing was to multiply and divide. And then later on, you learn the exponents. Okay, so when you have a problem with adding, subtracting, multiplying, dividing with exponents, you always end up doing the next easier thing with the powers themselves. So let's look at these 3 examples and we'll see what I mean by that. 2 to the third, that's 3 2s multiplied together. 2 to the fifth, that is 5 2s multiplied together. Oh, come on. There we go. So when we multiply all these things together, we actually have 8 2s multiplied together. So that is going to be 2 to the 8th. Notice what we ended up doing with the powers. We had a 3 and a 5. We just add those together. So when we multiply these 2 things, we end up adding the exponents. We were multiplying 2 to the third times 2 to the fifth. We end up doing the next easier thing, adding with the exponents. Three squared times 3. 3 squared is going to be 2 3's multiplied together. And then you bring the other 3 down. So now we have 3 3's multiplied together. That's going to be 3 to the third. So we have the power of 2 and the invisible power of 1, adding those together to get the new exponent. Four squared times 4 to the third. 4 squared is 2 4's multiplied together. 4 cubed is 3 4's multiplied together. So, in the grand end of things, we have a total of 5 numbers multiplied together. So that's 4 to the 5th. We took the power of 2 and another exponent of 3. We added them together to get the 5. When you multiply terms together, you add the
Good morning,
exponent.
Bulldogs. Please pause for a moment of silence.
Quotient rule.
Now, please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Have a great day, Bulldogs.
I have had so many problems with technology today setting up this video for you folks that I'm not going to try to edit that out or anything. We're just going to keep on going.
Quotient means division. So here we have 3 to the 5th divided by 3 to the 3rd. 3 to the 5th is 5 3's multiplied together. Three to the third on the bottom, there's 3 of them multiplied together. So when I want to simplify this, I can see that those 3's cancel out, these cancel out, those cancel out. I end up with 2 3's multiplied together, so that's 3 squared. Notice what happened here. We had a 5 as the exponent and a 3 as the exponent. We subtract those numbers and that gets us the power of the answer. So looking at our easy to hard diagram, when we divide terms, we end up doing the next easier thing with the exponents, which is subtract. Let's do the next couple. 5 to the 11th. Holy cow, why did I give that example? That's a lot of 5's. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the bottom, 3 of them. So we cross off 1, 2, 3. We end up with 8 5's on the top. So that's going to be 5 to the 8th. Okay, 8 to the 22nd power divided by 8 to the 20th. I am not going to write down 22 8's. It's too early in the morning. I haven't had my cup of coffee yet. Ain't doing it. I'm just going to do the shortcut. We have 22 and we have 20, so we subtract them. We end up with 8 to the 2nd power. Zero exponent rule. If we look at a graph, and here is, let's see here. One, two, three, 4, 5, 6. At the x equals 1 part, if I say 2 to the 1st power, I end up with 2. If I have 2 to the second power, I end up with 4. If I have 2 to the third power, it's 8. 2 to the fourth power, it's 16, way up here. And it makes a nice curve, like that. Okay, I was off with that one dot. Give me a break, it's early. If I do this kind of a graph with every single number, 3 to the first, 3 to the second, 3 to the third, and 4 to the first, 4 to the second, 4 to the third, we'll end up with an interesting thing. If I do another graph with 3 to the first, here, 3 to the second is going to be 9, and I can make do that with all the other numbers, and it turns out to be like this. If I do to the fourth, 4 to the first, 4 to the second, 4 to the third, I end up with another one that looks, oh come on, looks like this. They all end up crossing the y-axis at 1. So for that reason, we know that any number to the 0 power is 1. So 8 to the first is 1. 100 to the 0 power is 1. Negative exponents. Again, looking at the graphs of numbers to all the different exponents, we can see patterns, and I'm just going to tell you the end result. The end result is that we know that any negative exponent can be turned into a positive exponent by just moving it across the division bar. So right now we have here 6 to the negative 2. I can put that over 1 and nothing changes, right? Okay, now, if I move the top across the division bar, the exponent will change signs. So I'm going to put the 6 and the 2 on the bottom, but now that's going to be a positive 2. And on the top, I just have a 1 as a placeholder. 3 to the negative third, that's going to be the same thing as 1 over 3 to the positive third. 2 to the negative fifth is the same thing as 1 over 2 to the positive fifth. Whenever you move an exponent across the division bar, it's going to get the opposite sign. So I could be, let's throw in a couple other examples. If I had 4 to the second power, that's the same thing as 1 over 4 to the negative 2 power. And if I had 1 over 2 to the negative 7th, if I move this across the division bar, I'm going to get the same 2 and 7, but it's going to be a positive exponent. I can put the 1 on the bottom as a placeholder. So whether you move the power up to the top or move the power down to the bottom, you change its sign. Okay, now we have powers to powers. Remember that the power of 4 here is only acting on the parenthesis, so that means I have 4 sets of parentheses. 4, 1, 2, 3, 4. And in each parenthesis is a 2 squared. Each one of these 2 squareds is a 2 times 2. So now I have a total of 8 2's multiplied together. So that's 2 to the 8th power. Notice I could have gotten that by looking at my powers here and multiplying the 2 and the 4. So when you have a power raised to a power, you end up multiplying the exponent. Going back to our easy to hard diagram, when you have an exponent raised to another exponent, you do the next easier thing. In this case, multiply it. So the next one, 3 to the third squared. So the square is acting on the parentheses right below it. So I have 2 sets of parentheses with a power of 2. And in each parenthesis, I have the 3 squared. Whoop, I said squared. 3 to the third. And each one of these is 3 3s. So that's a grand total of 6 3s multiplied together, 3 to the 6th power. Again, I could have gotten that by just multiplying my 2 exponents. 3 times 2 would have gotten me the 6 right away. Okay, one more here. I'm not going to write out 31s. We're just going to do the shortcut. So, we have a power raised to a power. That's going to be 1 to the 60th power, which thankfully is just simply 1. So, refocusing. I want to simplify exponents. We've done it. We've done them all. Now, do these on your own, and I will show you the answers as I do it. But please pause the video and try to do these all on your own. Have you paused the video? Pause it. Here's some more problems for you to try out. I have some of the answers there already. Try to do these and see if you got the right answers.